So question 25, last question on the paper. The whole numbers from 1 to 2016 inclusive, that means it includes 1 and 2016, are written on a blackboard. Moritz underlines all of the multiples of 2 in red, all the multiples of 3 in blue, and all the multiples of 4 in green. How many numbers does Moritz underline exactly twice? Now I'm going to use my worked example because there's a lot of writing here. Multiples of 4 are also multiples of 2. Therefore, all multiples of 4 will be underlined at least twice. Any multiple of 3 and 4 will therefore be underlined 3 times. So I'm going through my logic here. The numbers underlined exactly twice are the multiples of 2 and 3, but not multiples of 4, and the multiples of 2 and 4, but not multiples of 3, because if they were, they'd be underlined 3 times. So if we think about which they are, multiples of 2 and 3, but not 4, 6, 18, 30, I've written them out and then crossed off the ones. They are the odd multiples of 6, 1 times 6, 3 times 6, and 5 times 6. So therefore 2 out of every 3 multiples of 4, looking at these multiples of 2 and 4, 2 out of every 3 multiples of 4, 4, 8, 12, 16, 20, 24. We can have 4 and 8, these will have 2 lines underneath them, and 16 and 20, but not 12 or 24. So then therefore I've used division. If I've got 2016, I want to know how many times we've got 6, how many multiples of 6 are there in 2016? Well, there are 336. I need only the odd ones, so that's half of them. So I've got 168 numbers that have got 2 underlines for this statement 1. And then to make this statement 2 work, we've got 2016 divided by 4, which gives us 504, but we want 2 out of every 3, which means that we're looking at 2/3 of 504, which when you work that through is 336. So we add those 2 together to get 504 numbers. Now, when you write it out like that, it makes so much sense. It took me a long time to get to that point. So I didn't start with all this logic. I had loads of pages to try and work through. I had several ways of getting to it. And then I realized that I needed to work on the logic. And in order to find it, this was then the key to being able to do it. As you can see, the math actually isn't that difficult. But with all of these questions, it's about understanding what that question is asking, picking the right bit of math from your toolkit and being able to smush it all together so that it gives you that answer. On this particular paper, there are no penalties for the wrong answer, so you can answer as many questions as you like. You're not expected to be able to do every question in the hour. So it's your choice whether you try every question and you take longer than an hour, or you limit yourself to an hour. My recommendation is to pick the questions that you want to do. Pick the questions that make sense to you, pick the questions that talk to you. And if you've got time at the end, then go back and do. But I would like you to be spending at least an hour being able to see how many questions that you do. As ever, I am here if you need anything, explaining again. Start by re-watching the videos just to see if the second time round makes any more sense. Otherwise, come back to me and just say, Mrs. Jones, question 5, I really don't understand this bit of it. I get stuck just here. Help. That is a lot more useful to me than actually going, question 5, I have no idea. Question 5, I'm stuck. Question 5, if you can be specific, well, I can do the first part of it and I get to this bit where I have to multiply these 2 numbers together, but I don't understand why you then add that. Please do that, and that will really help me to help you. So Goodbye for now. On Monday, I will send you the next paper. I will have a look at the score that you got on this one, so that I can decide whether this is the right level, whether we need to go easier, whether we need to go and step up the complexity of those questions or not. So goodbye for now, and I will see you on Monday. Bye.